Yeah, let's just get into it. So translating R, the objectives of this chapter or of this lesson is we're going to introduce why translating is useful. We're going to understand what domain-specific languages are. We're going to walk through how elements of functional programming is used to generate HTML. And then I thought we were going to walk through how elements of functional programming can be used to generate LaTeX, but we're not. So I left in the chat that I haven't used LaTeX since high school. So I can't confidently present, I can't even confidently present what I'm about to present right now, but I can't even begin to talk about LaTeX. But I feel like as long as we get the gist of how translating is used, because I feel like this chapter kind of wrapped up metaprogramming kind of nicely, then if you're familiar with LaTeX, then I think the points will translate well for LaTeX purposes. That's just another implementation of translation. Okay, so we're going to stick to HTML, and also for the sake of time, because this will probably take me the whole session. All right. So why? Well, translating code is really nice for consistency and readability. If you read through the chapter, you saw the example with SQL. So with the dbplyr package, there is the, sorry, let me move you guys, little faces. All right. You guys know that if you've ever worked with databases within R, you know the dbplyr package is kind of like the backend for dplyr, lets you like access tables remotely as if they were data frames in your session, like in memory data frames. And you can use functions like translate SQL to automatically convert dplyr into SQL queries. So it really is nice because you as an R programmer, a proficient R programmer, can write this, utilize these translation functions, and then collaborate with somebody who's not so proficient in SQL, and they could still understand it, right? So then there is the efficiency part, because once you have your translated code, so I'm about to get into it in a second, but like the domains specific language, you're basically creating like an API that is lets you generate SQL or LaTeX or HTML when you need it, but doesn't really like clutter the namespace like Hadley mentioned in the book. So it makes it more efficient. And then also it lets you express problems and solutions in the same level of abstraction. So you're writing R and you need to do some SQL queries, or you need to do some HTML. So you're going to do you're going to translate R by using a domain specific language, so that you don't need to rely on other libraries, which might make it challenging for non-SQL users in this example, like I mentioned earlier, to understand your code. Anyways, so in this SQL example, so we see here, use translate SQL. This is basically what's happening in the background. These functions have been written to take R functions and dplyr functions and basically translate them to pure SQL. So actually defaults to SQLite, but you can specify the flavor of SQL that you want. So not first in this vector of names, they translate SQL select == 7, then you get select == 7.0. There are special SQL caveats in these examples, but we're going to skip that for the time being. All right. So what are DSLs? So these are domain-specific languages, and I straight up took this from JetBrains.com. They had a really great explanation of domain-specific languages. Because if you're like me and you read DSLs in advanced R, I was kind of like, this is probably the second time in my life I've heard of domain-specific languages, so I'm going to go into it for a little bit. So what is it? It is a programming language with a higher level of abstraction optimized for a special class of problems. So a DSL uses the concepts and rules from the field or domain. So how is it different from any other programming language? Well, they're less complex than a general purpose language. So you develop them in close coordination with experts for which you are designing it for. Some of the main advantages of using a DSL is that it's efficient. So like in many cases, these aren't really intended to be used by, hardcore software folks, but mainly like programmers who are fluent in the domain that the DSL addresses. And then once you've gotten the language and some form of transformation engine, the DSL becomes a lot more efficient because you really don't have to do a lot of the grunt work manually. So if you read through the chapter, I got into the very end of the HTML section, and basically it just came down to like 4 lines of code that the DSL was just those 4 lines. That's what that means. So you don't really have to do all this manual HTML when you have like a nice function like that. If you're generating source code from your DSL program as opposed to really like interpreting it, there are domain-specific abstractions that prevent you from paying any runtime overhead, because the generator, like a compiler, can remove the abstractions and generate efficient code. So that's another really big advantage of using DSLs. And then you can have things like your thinking becomes a lot clearer because things are placed like you're within the domain that you're trying to write in. And then if you have a way of expressing domain concerns in a language that's closely aligned with the domain, it's a lot easier to write out your details. It's not colored by any kind of implementation. Let's see, independent of the target platform, better collaboration, and then just like increased quality, because if you find a bug, you get, it's better to maintain. Like the DSLs are easier to maintain, and you have better performance and fewer bugs and things like that. So there's a link right here. You can read all about DSLs on JetBrains. It was really helpful. Check it out if you are still a little bit unclear, but I think by the end of this section, you'll be a little bit more clear on DSLs. All right, so let's hop into HTML. So this is our
short question. Does that mean you could say DSL? Julia is DSL for math and statistics, more or less, people? Because you can write straight up math equation like math people would do. I think so.
In a sense, but Julia is a general purpose programming language, right? Well, it's not really general, it's actually, so Julia kind of is, I think of Julia as like a marriage between Python and R, because I feel like R would kind of fit in your example a little bit better. But Python is a very general purpose language where you can do a lot of math, stats, and modeling, but also development, like software development. And Julia's has kind of like, the little I know of Julia has kind of like combined the two. From what I've heard from a lot of Julia folks online. But I feel like the domain would be like HTML in this sense. So like we are writing in the R context. So we're writing R code, and we're needing to implement some HTML. We are not, let's say, HTML experts, but we are going to try and write up to, we're trying to abstract our, like, let's say our HTML problem up to R. So that would be, the domain would be HTML in this sense. So I'm understanding it correctly.
I feel like for me, I mean, it gets fuzzy at the edge, but I feel like a DSL is not a complete programming language. I mean, it gets fuzzy because like R is theoretically Excel is theoretically Turing complete. So you can do anything in Excel, but I would still call it a DSL for tabular data. But, you know, like people will call R a DSL for statistics, but it's not. It's a complete, you know, you can do anything in R. So, I mean, I feel like the example that they're giving in the chapter, the HTML thing, is definitely a DSL because what you're creating can't do everything. It can just create HTML. You know, and likewise with the tidy select DSL, that can't do everything. It can just make your life easier when you're selecting things and you know, working within dplyr.
That makes sense. So HTML in this sense, I guess I want to say it's just circumstantial, right? So you develop DSLs to address a certain need, a problem, circumstance, and go from there.
So with what Brett has just said, I was reading from the Wikipedia, they were saying R is a domain-specific language.
That doesn't make any sense.
I take offense at that when I hear people saying that, but,
Yeah.
but I'm an R guy, so.
Yeah, no.
Yeah.
Yeah.
Like, you know, would you write video games in R? No, typically not. But could you?
Somebody
Yes.
has with Shiny, Brett.
Yeah.
So Shiny folks develop video games. So that's arguable. So let's edit this Wikipedia page.
Yeah, it's
Okay.
a fuzzy definition at the edges.
You can simply edit the Wikipedia pages. Just
Yeah.
yeah.
Let's go and edit it then.
Yeah, exactly. All right. So, all right, a little basics on HTML. So I'm kind of familiar with the very basics of HTML. I'm not an HTML like pro. I have to use it occasionally with my Shiny app. So the basic structure of an HTML page is you usually have, you know, your opening tags, right? Your HTML, you're going to identify that you're going to use HTML. Then you have the body of your page. That's usually what it's followed by. And then you have the body of your page. And that could consist of tags like, you know, you have your divs, and then you have like your p tags, right, for paragraphs, and all of these tags. And a lot of these tags can have children, right? And then there are some that can't. So that are like image tags, for example, the IMG, right? These merely just have attributes. So all of these things have attributes. The p tag, for example, and the is one of them. So for example, elements that are kind of like your main tag that you're going to use, like your headings, your H1, your p tag. And then you have, those are called elements. And then you have your attributes that define specifics of your tag. So for example, they provide more information for the element, such as the source or a link's path. So if you use the A tag for a link, you have to specify the reference. So you specify href. So these are like key value pairs. And then there are things called void tags. Void tags do not have any children or content. So their attributes are what are the most important. They literally just is a tag, and it's opened with a bracket image, and then the attributes of the image like source, width and height, and then closed, versus your versus the typical element structure, which is like P, like you have P open close bracket, like in an open close bracket, text, and then followed by your closing tag with it, which has a forward slash. I was just these mixed up, and followed by the P. So that's basically HTML, and it's really fun to look at if you ever inspect a page. So here's that JetBrains page that I basically took straight up plagiarized on my, I'm sorry, this is recorded. I borrowed information from for this definition, and you can inspect it and you can see, you know, you have your little clicky, that the little click button here, and you can click on the section of the page that you want to see, and you can see it's nested. So there are all these nested divs, and you can see that this div has the class of WT row size M, and so, and this P has WT text to WT text to flow. So those are that's kind of the information that we want to extract when we develop our DSL in this example, in the coming example, this kind of thing. But then you can see here, like things like strong, for example, these are going to be the children of the P tag, or like italicized, the italic, the I tag with B for, is B bold?
Yeah. Oh,
what's strong?
is the P? That's like how you say it, a new line, and
it's a paragraph.
Yeah, a paragraph, exactly.
But the B, like the B is in boy.
Yeah, that's bold. So that's for.
And what is strong? What's the difference between B and strong?
A what?
And strong.
Oh, you can use both.
They're synonymous.
Yeah.
So bold defines bold type, whereas strong and an emphasis are like more, what's the word I'm looking for? Like thematic. So you can define those. So you'll define those in your CSS to be like whatever you want to, like, you know, be various levels of emphasis.
Got you. Okay, got you. All right, so here's our objective for the DSL. We have this, we want to be able to make this chunk of HTML. We have our body, and within our body, we have a level 1 header that has the ID called first, and it's called a heading. Within it is the text a heading. We have our P tag that says some text, and this is the actual and symbol. So we have to escape it. So we escape the and symbol by using the ampersand amp semicolon, and then some bold text with the B tags, and then closing P tag. And then we have an image, and this would be our void tag, which basically specifies the source and the dimensions of the image, followed by its the closing slash. And then we're going to make this with this. So this is the 4 lines of code I was referring to earlier. So this is essentially the solution. This is our DSL for that we're gonna create. All right, so yeah, so I mentioned follows the same nesting structure. Oh yeah, Hadley mentioned one thing to notice, that the DSL follows the same nesting structure. Named arguments become the attributes. So like these arguments right here is these arguments are the attributes of H1. So you have the ID, and then you actually have the text that goes in it, followed by the P, and you're going to give this is a argument as well, and then followed by the image function. So these are individual functions that follow the same nesting structure as the HTML chunk would be. All right, so let's start with escaping. So this is one of the more fundamental things that we have to get solidified, because otherwise things are going to just break, right? So there are a lot of characters that will break your code, such as the ampersand, the greater than, and the less than. So they need to be, when you're passing in, when you're writing the DSL and the functions, you need to make sure that they're automatically escaped while making sure that they're not doubly escaped, if that makes sense, because you could end up doubly escaping them, and then you're going to end up with the ampersand AMP semicolon in your output, essentially. So the way we're going to do this is by creating an S3 class for distinguishing HTML from text. So we have our HTML, which there are two methods. So in this escape class. So, well, first we're going to create our HTML function, which basically has X and passes in the class. Sorry, this ran off the page. But it's advr_HTML is the class. And then we take advr_HTML and we assign the print, what is the right word, method to this class, and which takes in X, and then we have our ... and then we assign something called out. We paste the HTML tag to X and assign it to something called out, and then we concatenate. And I'm going to show you this code in a second. So I'm about to switch over to RStudio because it ran off my page and I can't get the scrolly things to, yeah, when I use the scrolly thingy, it switches slides. But then we have to also define, so we've defined our HTML function. So this basically says, okay, this thing is HTML. But now we have to also define our escape function. And this function is, there are two methods in this class. So you see here we're using the use method function escape. So basically we're saying, okay, so there is a character method for this generic class, and there's an advr HTML. So I think escape here is the class, and the character and the HTML are the methods, because one is going to define, these are characters, this is regular text, and then this is HTML. So does that make sense? The first allows you to escape the characters, and the second is for when you don't need to escape them. Basically, it just returns itself. Did I say that right? I kind of missed some of the last few sessions. So the generic classes and the methods in the classes. So I think,
yeah, that's right. It'll dispatch on the class of the object. So if it's an advr HTML object, it'll just return the object, and if it's a character object, then it'll do the escaping of with the ampersands and stuff.
Awesome. Okay, so and with that, I am going to open the RStudio window. And so now hopefully you can see, so we have that function here, and I'm going to run it. and we have the print method. So here's the class. So we've identified specified the class and the print method for that, which basically wraps HTML brackets around whatever you pass in. So notice that there's a concatenate, paste, and an str wrap. So take this out object, str wrap it, collapse with a new line, and then concatenate that with the new line separated by a blank space. So if I run this and I run HTML hello cohort 5, you end up getting the HTML hello cohort 5. Now I don't see like the invocation of line 10 with the new lines. This was a little bit difficult for me to interpret, but it printed essentially HTML hello cohort 5. All right, so this is the other one. So that was basically printing. And then we have the escape when we need to escape characters. So if I run line 17, we have the new escape class, and then we have the character method, and we have the when we need to escape, and then when we don't need to escape. So let's see. I did some checks to see if it works. This was what was in the book. So you can do escape, this is some text, and you get HTML, this is some text, which you get that because it's going to print the HTML brackets because it calls the HTML function that we defined earlier inside it. And then invokes the print method. And then we have, all right, what happens if we have the greater than sign and a less than sign and an ampersand sign? So you know all these things need to get escaped. So you end up getting the correct form. So you get X ampersand GT semicolon 1 ampersand semicolon Y, the less than sign. You can even double escape, and that's not a problem. So you have, you're going to escape this, and then you're going to escape it again. So if I were to run this, you get, this is some text, 1 is greater than 2. And then you can escape it again, and you get the same exact thing. So it's not going to cause, I think the point is just to say that it's not going to cause any problems. And then if you know that you have some HTML that doesn't get escaped, so this is straight up HTML. This is not something that needs to be translated. You can call the HTML function explicitly, and then it's run that in escape. Now, I think I ran this independently, and you just get HTML, and then you get the HR tag. But if you run the whole thing, it's the same, you get the same output. So I'm not entirely sure why this was wrapped in an escape, because we know it doesn't need to get escape, but maybe it's just a safe, a safety net or whatever. Okay. All right, let's go back to the slides because we're going to talk about the R lang list too in just a second.
Hey, a quick question. On that print method, there was a ... Is that necessary?
Let me see. I think so, because I think in theory you could pass in multiple things, right? The dot 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 are the dynamic dots, so meaning that you can pass in multiple arguments, not just like the one x, like the one object, or maybe even a list of objects. But actually, when I think about it, I don't know if a list of objects would work here, because then you would have, you may run into.
So can I jump in? I think that dot 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 has no meaning here, because you would have to also use the dot 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 inside your functions, which you later define more or less. So the dot 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 there's no use in there. But which when you throw in a vector of strings in your HTML with your hello cohort 5, that's where your new line will happen. So if you throw in there a vector and a second thing, then you see your new line.
Wait, that has nothing to do with the dot dot dots though, right?
No,
No,
that was just the answer why she
Yes,
couldn't see
well-
the new line.
Yeah, but then now,
Because when I was reading this chapter, I thought it had to do with attributes, like, you know, those href tag on an image or something. But I could be wrong.
but
I'm not sure if
this
that's
is,
good.
well, yes, I think I know what you're talking about, but this is just merely escaping characters. So in this step, we're merely just printing what you've passed in and including the HTML tag, and then escaping bad characters. So I don't know, like we haven't added classes, so
No, you don't escape here anything.
yeah, I don't know. Yeah, down here we are,
So
because eventually this chunk is essentially for escaping. That's like the helper function that goes into the.
I mean that the output of escape character must be a class of HTML, because otherwise exactly the double escaping would happen.
Is it possible that
if you delete this HTML_X and then you make your example with escape, you will see that the double escape will probably happen.
Yeah.
Yeah.
I get that. So, but maybe it's in this context that the dot 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 might be necessary.
Yeah, it's later on, I think, necessary, because it gets pushed through multiple functions.
Yeah, because I remember, okay, so this HTML function is going to be used in about a couple steps.
To be precise, that's not really a function, that's a constructor of the class. So what this function does is construct your advanced HTML class.
Is that what this?
Yeah, so that what you see here, that's a constructor for S3 class.
Okay. All right.
So everything you throw in there will be an advanced HTML class. So that's why it's called constructor. With this function, you construct an object of S3.
Okay, that makes sense. So yeah, then we have those dot dot dots are probably going to be useful, they are going to be useful in about a few steps when we call upon this S3 class. All right, moving forward. All right. Man, you guys were like blowing up the chat. You're so busy. I have FOMO. Am I looking at the right thing? You guys can see the slides?
Yep.
Okay, so we just, all right, we went through escaping, and now we need to work through basic tags. So we're gonna basically start small, start with the P tag, and then work towards generalizing it. So P is one of the more common tags, and it has children. So the first step that we want to do, so we have this, this is the objective for the P tag. So we have some text, ampersand, some bold text. So we have the children of the P tag, which is B, and then an ampersand. So at this moment, it's not really possible to put all the attributes of P because of volume, and sometimes you can have some custom attributes. So the way we're going to do this is we are going to create a function called P that takes in an argument followed by a B argument, followed by a B function and an I function. So first thing that we're going to do is we need to separate the elements that are named versus unnamed. So, and that's going to be done using rlang list2. That's what this is right here. So you pass in these ... dots to list2. Rlang list2 basically just collects arguments via dynamic dots. I'm not very clear. I don't remember how it differentiates from list ... what list2 improves on, like what kind of features list2 enables. But then it's going to check with this if else, with this conditional, if the arguments are named or not. So if they are named, then if is null names also, if they're not named, then just return false, the length of this dot, the length of this object. Otherwise, is named is going to be the names that are not equal to a blank space. And then it's going to return a list of the named elements and then the list of the unnamed ones. And remember, the named objects, let me check my verbiage. Named components are things like the P tag, and unnamed ones are things like the image tag. So let's switch back to our studio. And so we have now that function. But before I went through the function, I wanted to check on list2. So this is out of the documentation of list2. Basically, it's creating a function called numeric. And what numeric does is it's going to pass in, so it's a function with the the dynamic dots, and you can pass in 1, 2, 3. And if you look at numeric, you see that, oops, I don't want that. I'm just going to run this. You get 1, 2, 3, a vector of three numbers. And if you do names of X, you get null. They're unnamed. But if I were to pass in named, if I were to name them the same numbers, you get them back named. So I can do Y, and I can look at names, and you get ABC. But you could also, because of the dots, you could also pass in expressions. So I can do this function and pass in a 1, but also the expression Y, this thing. So, and if I were to do that, I actually get the first element, which is unnamed, followed by ABC, which are named. And that's with the triple bang. So triple bang takes a list of expressions. And then you could not only use the triple bang, but you could also assign an expression, assign a number to an expression. So by using the double bang and the colon equal operator. And that works just fine too. And now you have a new named thing called F, which is assigned 4. So that's how the list 2 works in this instance. And that's kind of how it's going to work in our partition step. So what I just mentioned earlier, so we have the dots partition, and dots partition takes in those the dots, the dynamic dots, assigns it to an object named dots, and then it says if it's null, return false as the name, otherwise keep the name, and then like I said, return a list of named and unnamed elements. So these are like classes and IDs. Unnamed are things like texts, like the text. Okay. All right, so this one was a little bit tricky. We have to actually now create the function for the p tag. He sources a script called DSL HTML attributes.r. Says it's very weird. To be honest, it's with a little bit of time, you could probably get it, but I didn't go into it into too much detail. But essentially, it's going to check the to see if there are children, and yeah, I don't even know why I went to this slide, because the best way to look at this is to actually just show you how it works. So here is that that source code, that code he was sourcing. So you have the HTML attributes, and then we have the P function. Oh shoot, I forgot to add it in here. And so if I were to run this function, which is creates the P, you end up getting, right, some text followed by the P opening and closing brackets. Some text given, now you've specified an attribute, which is ID equals my ID. And then some text And then you end up getting, so you pass some more attributes. So class equals important, data value equals 10, and then some text. So that's, if we look here, we use the dots partition. So the first line of this function basically separates which arguments that you pass in are named and which are unnamed. Then we have the HTML attributes function from this script that he stores, which basically grabs the name value pairs. So if we look at HTML attributes, we you see that it's a function that accepts a list, and that if the list is 0, then return nothing. Otherwise, it takes uses map to char the names of the list, and then runs that on the HTML attribute function, which is defined below. So without getting into this too much, this really just pulls the HTML, the name value pairs from your named arguments, your named arguments. And then the children object is basically checking to see if there are children in your tag. So line 332 uses map char, takes dots, the unnamed part of that list, and escapes it. So I ran, and then the last part of this puts it all together. So you have the paste function within the paste function. So here's that HTML again. I think that was Juan that asked that question. So here's the HTML class that takes in paste. So I think this is where that ... is, because of it's an expression. I don't think it would work otherwise.
It would still work. That has nothing to do with it.
It's what?
That has nothing to do with it. So here, what is happening, your inner paste is first evaluated, then your outer paste is evaluated, and then it gets an HTML. It doesn't matter. So yeah.
Yes, because you're basically, okay, so you're pasting in here your P followed by the attributes, closing bracket, then you're pasting in the any children collapsed by an empty space, and then close bracket, paste that all together, and then pass that as an HTML class. Okay, so we're still trying to figure out this ... thing for HTML. So yeah, so if you actually look at dots, if we were to, I had actually run this on, what did I run this on? I think I just did it on, anyways, I can't remember, but, oh, I restarted my.
Are we doing a little debugging session?
I don't know what I did here. So I was just going to, I was very curious to see what was going into dots partition, particularly dots named and unnamed. And I think that probably was in this part right here. So I had partition named, it's not named. Oh shoot. What did I do? Oh, I think I had the, yeah, it was up here. I had the browser on. I had the browser on when I was running these examples. so I could see how it behaves, and this in fact returns a list. And so I called list 2. So dots is actually a list. And so if you go back, sorry, we go back here to the P function, this is actually going to be a list. Dots is going to hold a list of the 2 things. It's a list of 2 lists. The first list is going to have the unnamed, and the second list is going to have the named. Okay, there we go. So now we see what P returns. So we've essentially created a pretty simple function for P. And now we need to generalize it for the rest of the tags. So I've run this, and you can see that you pass them some text. If you pass them some some attributes, they get treated as such. So these class equals important. This is where the additional attributes gets pulled from the HTML attributes. Yeah. So this is a name thing. So this is going to be a named. This is named data value equals 10. So these are all going to go here, and this HTML attributes function is going to pull out the name value pairs, and then check to see if there are any unnamed, and then map that to this state function, which in these examples that he provided, there were none. Yeah, except for the quotes. So the utilization of the quotes. I think that was one thing that he also mentioned to be mindful of. So this gets converted, the double quotes gets converted to single quotes, but these backticks are going to be used for your value, because we have like your attributes like height and width for image, and then for this data value attribute, those have to go in quotes. Okay. So we've created the P function. So let's go back, and now let's generalize this for more tags. So we need to create a tag function, which basically says, let's generalize P for all other tags like B. And the way we're going to do this is we're going to take pretty much the same code that we use for the P function, but we're going to create a new function with rlang's new function, this one. Then we are going to wrap the helper functions within the expr. And this is what we've seen this already from the P function, and then which partitions the arguments, get the attributes, get the children, and then put them all together in a nested paste function. I'm thinking about this because this has to be this bang bang in front of the paste. It has to be, because they're expressions, they have to be you need to have these bang bangs in front of the paste, otherwise the paste is going to show up in your output. Maybe is that why we need the ... in HTML? So you can have, I'm trying to make it work. I'm trying to make it work.
I still believe it has no use in the example. I think he simply loves to do it. It would only have a use if you're, so it's not in the HTML, your ... It's actually in the print. So it has only use if you would use the print further down.
I don't know. Like what I guess just like sprinkle some ... dots in all the functions. I don't know.
If in doubt.
I know.
I've-
Just like
every
sprinkle
time we
them
add
in.
something more to this, I keep on removing the ... from that function and trying it again, and it always works without the ... so far.
Yeah.
Yeah.
Okay.
He simply likes it because you can extend it really easily then. So you could throw in ... in a further down print function. So yeah.
All right. So we're going to test see if this theory works. So essentially, the last part of this function, of this tag function, is called caller ends. I had no idea what the heck this was doing. And apparently, caller end returns the object into the environment in which the function was called, not from which it was created, which is I'm still trying to wrap my head around. It's tricky. So you have to put this in there. Otherwise, it will get lost in the function environment, not up. So like if you were to call tag from a global environment, you would want your output to also be in the global environment, not in the function environment. If I'm understanding that correctly. But then again, I don't understand how.
I think that's
I'm not
right.
sure.
Yeah, Chivan, you can explain it. I think it was your chapter.
You want me to explain this?
No, I mean, you're kind of right. The problem is if you don't do it, you are already inside the function. So the tag, so the new function is inside the function. And if you would not do caller env, you would always be in this environment of this function of the tag function. So it's correct. And the caller env will give you the global or more or less the environment where you called it. So in the down there, you call tag B in your global environment. So your generated function will use further down the global environment or what you give it. I mean, you have R open. The best thing is just run the code and then call P or I without any input when you see it.
Yeah. Okay. Before I open R, let me see. Okay, so this is void tags. So we had to create a function. So I'm gonna go into this. Yeah, before I open R again. So we've created the tag function that basically took the meat of the tag function is what we've used in the P to create the P function, except now we've wrapped it in an expr. And then I'm not entirely sure. I think I might have an idea of what this is for. You're basically exprs with the ... equals nothing. I think this is for naming. So you have your new function and then you pass in the ... and you're basically naming it nothing, like a blank space. So you're assigning that thing, you're basically naming that unnamed argument, I think, to a blank space. I think, and then the meat of this is wrapped into an expression, and then you use the caller, you call caller env at the end of it to make sure that the environment is, you're using the tag function in the correct environment. You don't get stuck in some lower level environment. Now for void tags, it's kind of similar, but for this particular instance, you have to make sure that you include a stop so that it produces an error if the tag is unnamed, right? So remember, void tags have no children; they only have attributes. So we have to make sure that nothing is passed in, nothing named, nothing unnamed is passed in. Sorry. All right, so let's walk through it. And let me open up RStudio again. So we have our tag function, and this is a general tag function. This is a generalized tag function. So if I run it, we see that, yeah, the expers on line 92, I think the name is this ... and the argument is missing, or I have it backwards. But either way, its purpose, I'm not entirely clear on. So we've used new function, and we are basically, I think, giving it a blank name, the argument a blank name. Yeah, this line I'm not so clear on. And then we have our three main executions, which is the DOS partitions, HTML attributes, and grabbing the children. And then essentially we have our HTML class in which we have nested pastes inside. So we have to include our bang bang operator. Oh, me, left myself a note. Bang bang operator is included here so that it is evaluated. Otherwise, you're going to have quote unquote paste 0 in your return tag. So basically, it's saying evaluate the internal paste first. So open the tag with its attributes right here. So evaluate this first with your open bracket, the tag that you are passing in with its attributes, and then include the children if there are any, and then close the tag with another bang bang operator and the tag itself and the closing bracket. And then the last thing that's returned in this function is the environment, making, I don't know, caller env, like I said, if you call this from the global, it's gonna be returned in the global. So if I do tag of B, you see that it returns the function. Yeah, it's just going to return the function. But you can see that it pastes B in here. So we have HTML, paste B, attributes, paste children, blah, blah, blah. So it inserted B and then the closing bracket down here. Yeah, and then we have, so Hannes was just mentioning that if we don't include the caller env, like what would happen?
We already had the discussion in the chat. Caller env is actually the default value.
The default environment?
I mean, Brett is actually testing it, I think, and in the help, the default for environment is caller env.
Yeah, I saw the difference it made by commenting it out, but I didn't really understand what it means. So like if it's commented out and you run tag B, it gives you it returns an environment with the function that you're generating. Whereas if you have color env in there, it doesn't, which I think means that it's the global environment.
Okay.
Or
Okay.
running it in the global environment. So like if you look in my global environment right now, you can see that I have the tag function right here. So this tag function is being called from within my global environment.
Oh,
But in theory, it could be in some other environment.
Yeah, I think I have an idea. I haven't tested it yet, but so coming up, we're gonna use map to make the whole list of functions for all the HTML tags. So that would be executed from within the environment that map executes in. So I think by saying, wait, but if you say color env, then it's the environment that map is executing in, not the global environment.
Right. So I
I'm
don't.
confused.
My confusion is that like why you have to specify color env and then why. Yeah, that's basically.
So I think is you don't specify color env. You when you call color env here, it will use the environment where you called your function. So if you write a simple function, I posted in the chat, simple function, and then you print color env, you will see that the output will be the global environment. So you should not see here color env. You must think about it that you get the output here of color env and not a function. So it will not stay color env. It will already insert something.
Okay.
I think that's how it works.
Does it maybe have something to do with down below putting all these functions into a list rather than into the global environment?
Where does that happen?
Oh, so later, yeah.
Yeah, and basically to wrap it all up, so even in the void tag function, it's also being called here, except we have an abort. Here we're specifying a vector of all the, what in the heck? Oh, it's because this is Sharingan and it's known reader is on. Let me stop server. Whatever. Okay. So we have a vector of sorry guys.
Do you want to just put it in the chat?
I'm gonna hide my meeting controls so that I can actually have our studio work. Okay. Okay, here we go. All right, so right now we have a vector of tags. So A, here's B, here is div, whatever. And then we also have a vector of void tags. One of the things that he mentioned was that you need to be careful of the tags that clash with base R functions. And the way to do that is basically to make sure, one, they're not preloaded in your global, or you can actually just put the tags that you need into a list, pass them in a list. But essentially, you have this named list that includes the tags. So all these tags that like the vector of 94 tags, pass to set names, pass to map. So I think this is what Brett was talking about earlier. And so these things, so like if you run, I wonder if this will work. You basically are going to run this vector of tags through the tag function. But you're also going to, hold on. You're also going to set names. What is this? Okay, so you basically set the name. So the tags themselves are character, but then you're going to name them with themselves. And then pass that to the tag function. So basically now every single tag has its own function. And it's same for the void tag. So if you actually run HTML tags, you get a large list of functions, 110. And if you look at them, it is, yeah, a list of functions, which includes the environment. And right now, all the environments, why it's not the same? Wouldn't they be the same because I called them from global? Or are these numbers not, they don't mean anything?
No, I think you're right. I think they each have a different environment.
But then now that just makes me even more confused on why we have caller ends at the end of both of those functions, because that seems to me like a consistency thing.
I don't know how I can describe it. Each function has its own environment. So your function cannot be the global environment. The thing is, you're creating,
okay.
you are creating a function inside the function.
Okay.
And you want the creation of this function to be using the outside, more or less. I'm trying to draw a sample together, but
I think I know. I think I see what you're getting at. So each of these functions that we've created now for each tag is going to have its own unique environment. But when we actually go to use them, we want them to be in whatever environment that we are in. Not from which they were, not the environment from which they were created in. So like, I don't want to be in this environment. I want to be, if I'm working in global, if I'm calling A, the function A, I want to be in my global, I want it to return the output to my global environment. Is that what you're getting at?
I'm still back on why they have their own environment, but
each function has their own environment.
I think it's because of the way map works.
Well,
I mean, if they have not their own environment and you would define something in one function, it would be also be used in the other function, which would be a little bit, how could I say it, not correct.
Yeah, you just don't want the variables to cross each other, right? Between functions. I think that's why they have their own environments. And then you can call them from like a global environment or whatever. I think that's my understanding.
Oh, right. So if any of your tag attributes yeah, so you don't step on the other tag attributes, I think.
Yeah, you don't want to be pulling dots from when you're trying to pull it from a side.
Maybe this is just one of those things I accept.
Because if you look at the body of those functions, the dots are in everywhere. So you just don't want them to cross each other
Yeah.
by having their own environment.
Gotta sprinkle those dots in. And they're there for a reason. So, okay. So, okay. So, what time is it? Oh, is it 2:51 already? All right. So we're basically done. We've created the list of functions that we need to call from. All the tags now have a function. And so, for example, if we want to call one, we're going to call HTML $P, and we're going to pass in some text, and then we're going to pass in actually another function, the B function, and the italics function, and we're going to specify a class. And when we actually run this function, we end up getting the right HTML, right? We get the actual HTML translation. And this is actually really nice because this reminds me of Shiny. This is probably like a low level or not low level, very like high level abstraction of how maybe the tags were built in Shiny. Because you call like tags $P, tags $H1, for example. And then finally we get the DSL. So once we have all these little components, like we've built all these components, we're going to put it together, and we are going to basically have this function that takes the code, and you basically quote that code. So you basically, this is the environment in which you call the function. So code is holding an environment, and then you transform. Now this is where I kind of got a little lost. Basically, I was lost all up and down this chapter, but basically you transform that data into a data mask so you can allow closures. So by doing eval tidy code on two HTML tags, this allows you to pass in the HTML tags list as the data object to this closure, to the object code, which is a closure.
What's HTML tags again? Is it just a list of every HTML tag?
Yeah, this is that
Vector?
list.
Okay.
That's the list that has like all of the tags, like
Okay.
the list of functions. So like all these functions, basically eval tidy, use eval tidy on that list of functions into code.
Yeah. If anyone's unclear about this, I covered this last week. You turn the
Yes.
code into a closure, holding an expression in an environment, and you can use the HTML tags to find, the tags like P, strong, whatever, and then use that into your code, which is a closure. It's usually done with a data frame, but they did it with a list here. So you're getting a bunch of stuff from the large list and then using that definition into your closure.
Yeah, that makes sense. So then that's it essentially. That's the DSL. And then this is the example. So you basically grab this with HTML, and we're where we started. We're basically where we started, where we have our body tag, and we have our function now. These are now our functions. We have our H1 function with our attributes. We have our P function, and then we have our void tag or void function image with its attributes as well. And if you run this line, Oh, I didn't run this part. Then you end up getting the whole shebang. So this is what we were trying to get at the very beginning of this chapter, and now we've created it. So essentially, we have all the components. I guess this is the DSL for incorporating some HTML into your code. Aren't you glad I didn't do LaTeX?
I like that the way they've done this, it's like it's valid R syntax. It's not, I mean, it's a DSL, but it's, yeah, I don't know how to quite get that out, but it's like, yeah, I feel like a lot of languages would do this a little bit differently, but I like the way it's done here. I don't think I could redo this myself, but
I don't either. I really don't think, like, if I had to do this for, I don't know. I don't even know. Like, I would say, like, if I had to do this for XML, no.
yeah, I mean, XML is very similar, so it should be pretty much the same model. But, you know, I'd
couldn't
still
think
have
of
the
an
exact
example.
same. Well, no, I mean, that's a good example, because that's one that I think, you know, maybe we could do, but we'd still have the exact same questions about what the parts that we didn't understand do. You know, like at the
Well,
very
like
end of
any
this.
of the other languages, like, could you could in theory do this for like SAS, right? The same sort of translation.
Yeah, you might just have to think about the syntax of what you're translating into. But you know, like, I mean, that's why the XML example is a good one, because it's pretty much the same syntax as HTML. So you can, you know, it's like the nested tag structure.
It's even easier because you don't have the special tags, so the closed tags and stuff like this.
Yeah, but what about like something like JSON? Did the R JSON engines, did they use this approach to generating JSON and interpreting JSON?
It's similar. It's very similar to SQL. So like the SQL translation, though, yeah, you can basically take, like with JSON Lite and some of the JSON packages that I've seen, will basically convert a data frame, like the data structure, and then make it like a JSON format where you have your I can't even think anymore. My brain's fried. The classes and the values, the key, whatever.
The key value pairs, yeah.
Yeah, the key value pairs.
I mean, the thing is, you don't want anything simply your finished product to be translated. You want something which you can build a product. Like in your HTML example, you want to use the tags. You don't have a finished thing and want to simply translate it. You want to build with it. That's the DSL reason. Yeah.
Right. So I mean, like in this example, instead of just, you know, saying, you know, body H1 and then you know, putting in text strings for the heading, and you could, you know, you could code those. So you can, yeah. So it's, yeah. So like the SQL one is interesting, because I still a lot of the time just use straight SQL and use something like glue SQL to interpolate it. But you know, if you have a domain-specific language like the dbplyr, then you can use all the, you know, all the stuff you know about how to generate code in R to generate your, you know.
I mean, one downside, which is never mentioned with all the stuff, is that if you have something new or something special which is not included in your DSL, you cannot write it, and then you have to hack it around again. And I noticed with other abstraction of SQL, I had a real problem, and I had to really hack around that I get my SQL code, my raw code, into the end product, because it was not supported.
Right. So if, HTML is pretty well defined, but if it wasn't, if you can kind of, if there could be additional tags in certain contexts, you'd have to use use that last part of the chapter to generate your HTML into an object and then edit that text.
Yeah. Yeah.
Yeah. I'm like I'm in the middle. I'm somewhere in the middle where I can see the benefits, but I'm not at the part where I'm like, oh my God, yeah, I'm gonna do this. It just seems a lot more work than I really want to put into it. I don't know.
I feel like that's the case for a lot of the advanced R stuff, but I feel like understanding some of this stuff helps you figure things out. Like I'm teaching a carpentry's art course in a couple months, and one of the things I want to include is like, okay, so you have you understand dplyr, you want to write a function with it. What's the minimum you have to know to be able to do that? You don't have to know everything about metaprogramming, but you do have to it's probably good to understand that that's what you're doing, and rather than just following a recipe. I mean, some people prefer to just follow a recipe, but I don't know, some people work better if they kind of know why it works.
Yeah, and also like for the methods, right? The generic classes and the methods. Like I probably would have done something like doing a bunch of conditional checks instead of writing methods. This has helped me kind of understand that stuff better. But as far as like writing a DSL and doing like translation, I'm still like, okay, it's not like apparent, obviously apparent.
And the whole topic about understanding what's happening behind the scenes. I had one case from a girlfriend, some genomics data, and she used a library, and we couldn't figure out why some rows were dropped, and there's an undocumented dropping based on some value in the source code. So what I just want to say is that sometimes, and if you are in science or something, not simply use a package because that's your algorithm also, you should properly safety check it if it's really doing what you want, more or less.
All right, guys, I gotta run. They're locking up shop, so I gotta go back to my own house.
Okay, see you.